Is it like 50?
50. Why?
Is it right?
I don't think so. What did you do?
Let me think.
Last time we think about vertically, right? Last question. The question we just did it.
I had no idea.
Well, it's kind of similar as the last one. Like if this is the this is use this one. If this is
But
the
when it says
horizontal,
like,
you wanna say something?
sorry, when it says how far does it travel horizontally, are we still finding delta y?
We find it delta x then. If we do want to find delta y, this is delta x. The delta y is called how far did they drop in 2 seconds, right?
Okay.
Or did it drop vertically? But we don't really say vertically, just did it drop. So assuming it's vertical, right? But when they say how far did it travel horizontally, it's not delta y, it's delta x. It's x direction, right? It's basically
So
finding this one,
previously
right?
we're finding, okay,
Or finding this, right? I mean,
okay.
oh, you find the delta y?
Pretty much.
Oh, so this is the question of design. One lets you see vertical direction, and this one is let you see x direction, horizontal direction, right?
Yeah.
So can we do a horizontal? If it now,
But I'm still not so sure how to do this.
how do you find horizontal one? What kind of motion is the horizontal motion?
Constant motion?
Yeah, constant velocity, right?
Yes.
So if we say it's just constant velocity, it's just for horizontal, it's just like, right? Constant velocity like this, right?
Yes.
So then constant velocity, how do you find the displacement? Constant velocity, how do you find displacement? For example, they tell you it's 15. You travel 15 meters for 1 second, right?
Yes.
So now it's 2 seconds. How far you go? For 1 second you go 15. Another
30.
second, yeah, 30, which is VT, right? Delta x equals to VT or V0 xt, right?
Yes.
We want to say V0x because we have V0y in a lot of situations. So that's why we run about V0x. Not only V0.
Yeah.
So is it making sense? You're forgetting constant velocity formula?
To be honest, I don't think I ever memorized it. If I did, I forgot.
Big five is right, but we emphasize the importance of big five all the time. But VT is actually more important. This is also the foundation how we got big five, actually.
Was it the foundation, the first formula?
Yeah, no. The foundation is constant velocities delta x equals to vt. So this is the not changing velocity, right? So that's why in the first velocity in the we say v average instead of constant velocity. Sadly, it changes, so we find v average, and the good thing is v0 plus v final or over 2. So that's why we write this one time t, which is delta x. So this is another way of this. Does that make sense?
Okay.
So that's why vt is the key, actually more fundamental than big five. Does that make
All
sense?
right.
Although we emphasize big five too much. Does that make sense?
Yeah.
Vt. This is also how far, like how we handle this kind of situation by approximation. Say we know how fast a person, they say I will get there, at 1 hour later. See, you know how fast you go, and you know the distance. So this is I say I will get there 2 hours later. I will get there 3 hours later. Does that make sense?
Yeah.
So you're using this, right? Does that make
Okay.
sense? Yeah. Otherwise, when people ask us when do you think you can get there, we never answer. We answer is because we know that formula.
I'd estimate.
Yeah. 24. So we think about vertically, we think about horizontally. Is that making sense?
Yes.
It depends on what they ask, or sometimes both. 24.
The velocity stays the same.
Yeah. Still, what's the velocity before? How does it horizontally?
This is confusing. I think Big Five was just easier right now, just
Yeah.
because we did so much practice, but
Yeah.
also because like it's finding what variables you're missing, substituting the ones you have, and solving for the one you don't have.
Yeah.
But I feel like this one is,
You
I
mean
don't
20?
know,
You mean 24?
like the horizontal ones.
Oh, it's constant velocity. You don't do much about this, right?
No.
Yeah, so it's still the same. Yeah. Wait, if it is still the same, how does it 1 second after longitude compared for horizontal velocity? Just the same, right? After the same.
Yeah, because it's constant velocity if it's horizontal.
Hmm. Or horizontal velocity doesn't change at all, right? This is focusing on one direction component. Horizontal velocity never changes in a projection. 25.
Can we do this one together as an example?
Yeah.
Because it's adding angles.
Yeah. Angle is although they add angles, but I can say horizontal. It's a projected, so it's a projectile question anyway, right? So horizontal and separate horizontal and separate vertical is still working, right? So if I draw it, it'll be something like this. Right? But if I separate it in two directions, and they say this is 30 degrees, let's say this is 30 degrees, and this is a 40. How long does it take? Will it take for the object to reach the top? Huh. Getting here, right?
Yes.
This is the object. Hmm. But think about the vertical or horizontal. Let's think about both. So if I draw it now, it'll be something more like this, like this. So one component horizontal is this, and the other component vertical is this, right?
Yes.
This one is complicated. We don't want to use it until necessary. And this one, so vertical and horizontal, which one do you think they are? How long,
Vertical.
yeah, yeah. How long does it take to reach the
Top.
top, right? The top is vertical, right? So this is the T they want to use, right?
Yeah.
They want to find out the T. And what we know is we have G acceleration, right?
Yes. And it's going to the top, so it's negative.
What else do we know? We know the V initial here.
A zero?
If you zero, you can't go up.
So V final is zero?
Yeah, V final is zero.
And V initial is 40?
Wait, when we
Because
say
it's like,
Vx, this is V0y, right? Not only it's V0, so V0 is 40, right? But that's in that direction, right? But we are talking
okay.
about vertical, so I'm probably gonna forget about, I'm gonna leave this graph in here, but draw a vertical one. G is still G, T is still something I wanna know, this is still zero. But I wanna know V0y, V0y is not V0, right?
Yeah.
How do I find V0y? So I'm gonna focus on V0 and V0y relationship. So this is V0, right? 30-degree, right?
Yes.
This is a 40. So this is parallelogram law. Do you remember?
No, but are you just using Pythagoras?
Not exactly. Oh, oh, that not this is 30-degree, not Pythagoras. Probably want to say
Like
trigonometry.
trigonometry?
Yeah, trigonometry.
Okay. Um,
So if we want to say,
horizontal, I could do um
forget about everything
wait, it's in
else.
my head. It's in my head. I promise. Like cos 30 divided by 40 equals horizontal.
Yeah, yeah. Cos 40. I mean cos 30-degree, right?
Yeah,
Equals
equal
to
cos over
this is
40.
V0x, V0y, V0x over 40, right?
Yes.
So we want to find what kind of V0? V0y. We want to find V0y, right? You're getting me, for this one, I get V0x, right?
Yeah.
How do I get V0y?
Why is y horizontal? Oh, okay. Um, I do sine.
Yeah, sine 30.
Keep thinking y is the horizontal instead of the vertical.
Oh, why?
I don't know.
Oh, we only say that because XY system, wait, familiar.
Yeah, I recognize.
It's not that necessary, this kind of like a variable letter. Well, let's just try to keep it simple, then we just use the one that we did a lot before. So Vy0 over 40, right?
Yes.
So what's V0y? You need
Didn't we just do sine 30 over 40?
Well, but you have to find a specific what's v0y. Because we kind of need it here. We have a g here. We have 0 here. We need a t here. So we're waiting for v0y to be a specific data. What's v0y then?
0.0125.
Wait, isn't that v0y use 40 times sine 30 degree?
Oops.
Uh,
20.
oh, you're using reading? That's why you get another number?
No, I accidentally clicked divide.
Oh,
Yeah,
that's
but I
20.
turned it to degree mode. Yes,
This is 20, right?
yes.
So return to my most focused diagram. You can't see most focused. I mean, at least the final diagram is, this is 20 then, right? So now
Yes.
everything comes down to this. 20, 0, 10, like this, and t. How do you find t then?
Wait, could you please repeat?
Well,
Like the last part about the t? So now I have v initial y is 20,
mhm.
and then,
The final is 0 because you're reaching the top.
yes,
And then the g acceleration or the acceleration is negative 10, right?
yes,
So
because it's going up.
can you find the time then, which is how long will it take?
So I use the big five.
Yeah,
Do I use the second one?
sure. That's the one that appeared most in that formula, right?
Sure.
V equals to v0 plus at. So how do you substitute?
40 minus 20 divided by -10, -2.
Oh, so it's probably the final is 0. So 0 equals to 20, right?
Wait, well then what about the 40?
But we don't use 40, we use 20.
So 40 is just irrelevant completely.
No. You get 20 from 40, right?
Um, yes,
Using trigonometry to get it there, right? And then
right.
when we
But
do
that's
it,
it.
yeah, when we do, that's why we always emphasize it's the separate motion. When you do that separate motion, do not think about this. Do not think about this. Does that make sense?
Okay.
Because we already separate. We say it can be separated. If you think about the other, and then you confuse yourself again.
Okay.
Does that make sense?
Yeah.
Mm.
So then it's positive 2.
Yeah, that's negative 10 and t, right?
Yes.
So positive. Yeah, use that. Remember to try to remember that one. Then the other one is totally irrelevant. Irrelevant, yes. But the other one is totally relevant because we separate. It's kind of like this. There are several pieces of that machine. Well, but if I only ask you this piece and I separate it, then you focus on this one only. Do not think about before you think about how they're related and everything. But now you only think about one. Don't think about that.
Okay.
Unless it's connected, influenced by the other one for some reason. Of course, other than that one piece, you connect with other, how you combine with other. That's it. It's important, but that's another question, right?
Yeah.
How high is this? You have a follow-up question.
So now I have to solve.
How high is the object? I erase everything. You
So
can
I have to
redraw it.
set for delta x now that I have time.
Yeah, yeah. Well, vertically, so we probably say delta y. Well, you can say delta x, which is the same thing.
I'm only saying delta x because of the formula, like the big five.
Yeah,
But I
yeah.
understand what you mean.
Yeah, because in the problem we're
Point.
gonna do later, sometimes they do both horizontal and vertical. So you if you both write delta x, you probably confuse yourself a little. But I do,
Probably.
yeah, but I do see people use delta x anyway. But they probably write some words like on the side, saying vertically and then horizontally delta x and vertically delta x, this kind of thing.
Yeah, I
Still a
got
little,
20.
yeah, big five, right?
Yes.
So that's the thing about the. That's why I said the phenomenon is always easy, right? And when we calculate, we simulate ourselves, which is not easy. Otherwise, I will make my own computer.
If you
But,
could.
yeah. Yeah. This is the thing about when we see human all the time, no surprise anymore sometimes. Then, but when you try to create a robot, you feel you have to learn a lot about humans.
Why?
Well, otherwise, how do you make a robot? Make it stronger, faster, more sophisticated, more intelligent, and kinder, hopefully.
But they're different than us. Like to be stronger, we have to work out. They don't. They just
Yeah,
need better motor machines and
yeah, but
things.
we learn it from we simulate human, just simulate no angel human kind of.
Fair point.
So which means when we simulate the something which happened in front of us without surprises, well, there are a lot of things we don't know about even our own. We just see it every day. Doesn't mean we know it.
Mm.
Oh, one of my favorite singer recently. I don't really listen to that much. She said something. So Scott, keep us, repeating our life again and again is because there's something deep in there. Mhm. I think it's probably true. No, it's definitely true.
Mm.
26. He wrote a song about it.
Let me
True.
try. I don't know.
And that's good for you too. Learning,
Why?
studying, doing the homework, most of the time.
Oh, I thought you said like that's good that I don't know the singer, and I was like, why?
Oh no. The good thing is we all repeating ourselves.
Okay. Is it 3 and 45?
3 and 45. 3 is the time, right?
Yes, like seconds.
Mm.
But then
45.
I'm not super sure about the travel horizontally.
3. Hmm. Wait, 3, you're using basically what we learned before, right? In the last question, right? In the previous question.
Yes.
But they are saying will be in, last time is to the top, right? This time
Yes.
he said be in the air, right? Do you think after the top it's in the air?
No, because it stops.
Wait,
What?
projectile,
Uh,
do you think it stopped? Freeze in the air,
no.
right? You can't
So
freeze
I
in the
doubled
air, right?
it, like 6.
Yes,
Okay.
because the other
So
part is this kind of motion, right? It's another 3, right? The basically
yeah.
symmetrical.
So then the
30.
other one is 90.
That I don't know. I only know 3 is the 6, which is probably the right one. How far does it travel? How do you do it?
I find out that
Sorry, it's a dog.
oh no,
It's
don't worry, it's okay.
just one second.
Don't worry, take your time.
Oh, okay. She was barking with to a purse.
Oh,
Yeah, the next the yard next or yard. Because it doesn't bark to the neighbors. It's neighbors child.
oh, that's good.
And then
Otherwise, the neighbors would complain.
you know the neighbors like at least it's a little bit far. She
Oh,
started to bark really loud.
like
Scared
how
me.
old is she?
Uh, not as old as 1 year. Like
Okay, that makes sense. That
7
makes sense.
or 8 months, I think.
They get better, I promise.
Really?
Yeah, it's like they also have like a period of time they just bite like a lot of things and it's like really playful, but like it gets better. Like they progressively gain more control and
Oh,
understanding of your command because like they're young, they're growing.
okay. This is my fourth dog, and I thought I got better, and then recently I found her bark a lot. The good
No,
thing
because
she never
every
bite.
dog is different.
She never bite anything. I mean, any person.
Not even when she's like teething.
No. Oh, it's not. Yeah, teething. Yeah, but not the
Yeah.
real kind of bite. But all the other dog when I raise them, like they try to bite a little, but when you have to teach them. But this one you don't have to teach. He doesn't really bite.
Oh, that's good.
Never. Which is good. Probably when we have little kids there, that's good. They know they never, she never bite, which is good.
Yeah. But like still like you also have to tell the kids to play gentle. Because like
But
sure they
they,
don't bite, but sometimes like if they get hurt badly or something, they might like nudge or defense. But not
yeah, yeah,
like
yeah, yeah. I
that's a
know.
personality thing too.
Yeah, yeah, yeah. I should probably come, but it's not that big dog.
Yeah.
It's Teddy with another kind of bigger
Oh,
dog. Have those.
love Teddy.
Yeah, it's a
Because that's what I
slightly.
had.
Oh, slightly greater than Teddy.
No, but they're different types of teddies. They're like the tiny teacup ones and they're like the gigantic ones.
Oh yes, I watched the other. There's a letter to God. It's a little. It's a real story. It's a kid with a cancer, and he wrote so
Hmm.
many letters to God. And he, in that movie, there is a big dog, which is a little scary, and turned out it's a teddy. Also not, probably not by.
They're kind. They're
Yeah,
breeded to be kind, but like every dog is
very
so.
big, but that is a teddy bear, teddy dog. That's for the first time I know. Now
Yeah,
then I know what you said. There's big teddy.
they are.
Yeah,
It's cute.
yeah. Still thinking all the time. So anyways, horizontal. How did you do it?
I
Sixes,
just
right?
solved for like the delta x using the first formula. Like I did
Delta
exactly how I
x.
did in the last question, basically.
Delta x equals to what?
45?
Wait. How do you do it? The process.
No, wait, 90, sorry.
How do you do it?
I did 1 over 2 times 30 times 6.
Wait. 1/2 is the vertical. Okay? That's the 30. That's 60. But he's thinking about how far horizontally. So it's not vertical. So you can't use that 30. Does that make sense? You can't use this
Okay.
30. That's vertical. You should say bye-bye to vertical. Now this is the first time we do it. We do it. This one is vertical. Yes, doing the right thing. But this one is horizontal. You can't think about vertical anymore. At least not all of them. You got to think about vertically.
Would I do
Vertic.
cos to find that length?
Yeah, you do cos.
But I get a nasty fraction, so I wasn't right. Like I wasn't sure if I was right.
Oh, that's okay. V
Right?
0x over 60 is cos 30, right? I mean,
Okay.
so that's why V0x is 60 times, you can use calculator to this one.
Yeah, I got that.
And then you can use this timing the 6 you have, right? Because in here, they use 3 seconds to get there. And in here, he used 3 seconds to get there, right? So totally it's going in the same direction, same velocity all the time. So you should use 6 times that, right? 6 times this, right?
I just times, I don't have to do like 1/2 or anything.
Mm, no, 1/2 is for big five. It's for constant acceleration. This one is constant velocity. Wow, you should totally make the difference between that. One is constant velocity, the one that we love the most. There only one formula.
Okay.
And well, uniform acceleration is not that fun because you have 5 formula basically.
Yeah.
Does that make sense?
I wish it was IB for a second because I know they would give it to you if it's IB.
Right?
Yeah, because IB, all like IB science exams or like social science even, sometimes they give you like data booklet and it has like a lot of formulas in it.
Oh.
Sometimes like the most easy ones are the most common ones, and sometimes they're like the hard ones.
So anyway, we're using delta x equals to v0x times t. Seconds.
Okay. So 311.8.
Yeah.
Okay.
So now you know there are 2 formulas, right? Delta x in vertical direction, I mean horizontal direction, and delta y in vertical direction, right?
Yeah.
Okay. And remember, this one is constant velocity. This one is a constant acceleration, which is a totally different situation, right?
Yes.
Oh, this one we think about vertically to get the time. And so this is the connection. The time in the air, the time vertically is also the time horizontally. That's the relationship, right? Other than the relationship, I also don't want to know vertical anymore since I want horizontal. Okay, unless I don't really have
Okay.
enough information, I get help from the other motion, the other separate motion.
All right. I was considering like maybe using cos.
No?
Um, because I remember in the very distant past we did this one question on the PPT
Yeah.
that was like there it had like friction and we were finding like F like force or something. And then we also had like angles and we were changing it depending on which we were looking for.
Oh yeah.
But then when I got a really bad decimal, I was not sure. So I
Oh,
just did what we did in the last question.
oh. Decimal, it's okay. This is physics. We
It
we
looks so
get
nasty.
yeah. This is the yeah real life. It is the data is say any data is gonna be so. Let's see.
Hmm.
It's just the they are extremely accurate calculated by God, but for us it's one. For example, how high you are, it will use forever to real now to know the real data right now. Even just how high you are. Can you imagine that?
Mm.
Yeah, the Bible says he measured it with his hand. Of course, God knows how much power he has. We just know the data, and we don't know. We have to calculate all the time. Do you want to do more exercise, or you want to move to another chapter?
Maybe I can have the exercise for homework.
Sure. And you can
Because
read
honestly,
the.
I'll be so honest. I'm so exhausted. I'd much rather take notes.
Uh, you're
Yeah.
still exhausted from the summer camp.
Yeah, because today was the last day, like clean up, like supposedly party, everything. But I'm gonna be back on the study grind starting from next week. I kind of have no choice. I have 2 more weeks of summer vacation.
Mhm. But you have
I will
better,
be rested.
but you have better energy stored, right? That's the question I want to ask.
No, because I did not rest at all. Like usually at this time, I'm in China, relaxing with
Hmm.
family, eating yummy food, probably
Yeah.
shopping on Taobao. But now
Hmm.
I'm like really burnt out. I have so much things I have to write and do, so much school things. And my textbook, I barely even look through them, even though I said I would. And I have 2 more weeks at SAT. So I'm very burnt out. I have like senioritis right now. I want to graduate, but I have to survive the year first.
Uh,
Mentally very burnt out.
Wait, I thought that's why I want to ask you. You like it, but you had to be sure that you got a somehow real little teeny vacation along the vacation.
I feel like being there is vacation, but as soon as it's like done and I remember all the things I have to do, it's not vacation, it's stress. But like when I'm there, I'm really happy. Like playing with these kids and like bringing them around. Like they're really fun.
Yeah.
Like even when they make me angry, like if they don't respect the teacher, like you're like, okay, come on, guys, listen. But like they're really sweet and it's fun
Really?
to
Tell
visit
me
them
about that.
because I know
Tell
half of them goes to like the
me.
elementary school and I'm in high school, so I'll visit.
Well, either it's only a phase because you're in the beginning,
It is. It is because
or I
we
really
have.
have to learn something from you.
Oh,
I never
I
really
think it
learned.
is a phase though, because we have like children from like pre-K 3 to like seventh and eighth grade, and now they're in fourth grade, and then you see the fifth graders are wild. They're
Hmm.
wild. So I think it's a phase. I don't know.
Hmm. Oh
But
yeah.
they're really
You
fun.
mean you mean
Like,
they listen to you, right?
yeah, like they still look up to you and admire
Yeah.
you to some sense. So they give you like
Oh
authority. But then in
yeah.
fifth grade, they're just monkeys. I'm not even kidding.
Yeah.
They're
Yeah.
jumping around everywhere and they're like snatching and taking things. And they're like, I'm my own boss. But like
Yeah.
fourth grade, it's like, okay, I'll listen to you. You're still like, you're still amazing and wonderful adult. I trust you. But fifth grade is
Oh
like, no, no. I hate
yeah.
everyone. Get away, you know? Um,
Yeah. Yeah. Mm. What happened? Yeah, it's true, actually.
Yeah, I think it's just phases, but it's still they're really nice.
Let's say example one. Do you see Newton? Remember Newton's law?
The third one or the like all three?
All three.
Like the first one, if something in motion stays in motion unless disturbed by an unbalanced force.
Yes.
And then the second one is the F, like Newton's equals mass times acceleration. Like F equals ma.
Yeah.
And then third one is for every reaction there's an equal reaction.
Okay, good. Let's do example one then.
Okay. Can we do this one together? Wait, no, wait. Yeah, can we do this one together?
You already see. They say net force required, which is
Yes.
the three law. Which one you want to use?
Second one.
Okay, sure. So F net or sigma F equals to ma, right? Is that,
Yes.
and what's m? 5,000. What's a?
7,500.
Hey, that is a is what?
Acceleration.
And
That's what I
this,
was wondering, shouldn't units be ms squared?
yeah, that's a good, very good observation. So this one is called 7,500 is what? It's velocity,
Velocity?
right? So you can't put velocity instead of acceleration, right?
But it's constant velocity, so my acceleration is
So acceleration.
0.
Yes, zero. Since Newton's
Okay.
second law is so powerful, we
Something
probably should
like
trust it. Although 5,000 times zero, it doesn't really make a lot of sense.
not at all.
Hmm.
There's no force because it's like emotion. Then it's
Yeah,
not disturbed by an unbalanced force. That's why the force is 0 because it's in
yes.
constant.
Yeah, so this
Okay.
is Newton's first law too, right?
Yes.
So this is a very, well, it's a kind of special step. Before we thought you need force to maintain, actually you need a force to change it a lot. Which means you need an extra force for Newton's first law. Because we have
Okay.
inertia. So we have the tendency of remain the previous motion. Example one. So just be careful with the formula and constant velocity. Just trap all that everywhere. Example two.
Mm, 8.
Yeah, this one is totally sigma f equals ma, right?
I almost squared 4 and I was going to say 16. I was like, what? Yeah, no, but it's 2 times 4.
3.
Three.
Yep.
Yay, I like this unit just because the first 3 questions sounds easy.
Yeah, formula is invisible principle.
One formula. So very good. That's what I like. Easy.
Yeah.
Yes.
And pretty
I
powerful.
like to challenge myself, not in solving No. I'd much rather challenge in concept or memorizing. I think that's why also I'm slightly better in biology.
Oh, they have more concept in
Slightly,
there?
it's just a little. It's more memorization. It's only memorization, correction, like very little solving. And if you do, is solving for like cells or something.
Mm. Yeah. Yeah, biology is a lot of memory.
Yeah,
Yeah, doctor is just the one who knows it all. Hmm.
somehow. I don't know how they do it.
It's okay. Doctors have ChatGPT with them right now to help them. How to do three then?
It's three, not three,
Oh, your final result is three. Okay, and also you need to know the direction because acceleration A have a direction. That's a vector.
right?
So even they didn't say magnitude, so you have to point out the direction.
How do
To
I
the
point
right.
out the direction? Oh, I write it on the top of the answer.
Yeah,
Oh,
to the
I
right.
remember.
Say to the
Yes.
left, you have to choose to the right. Right?
But don't I write it on F, not on the acceleration?
Well, also F is that acceleration is the same. F is to the right, F net is to the right, and F acceleration also is to the right. Then again,
Okay. Yeah.
because acceleration also have direction. How about five? I mean four.
Wait, college, the board is the one that's doing AP Physics 1.
Yeah,
So my exam is digital.
yeah.
Really? And is it only multiple choice? No, there
No,
has to
no,
be
no.
open-ended,
There's
right?
there's for yeah, there's for yourself.
Okay.
There
Then
used
that's
to be
useless.
paper, and now AP also
No,
changed
I don't
into.
want paper.
You
Wait,
want a
but is
paper?
all the AP digital, like all the AP courses?
Oh, I only know physics and the calculus. Yeah. Well,
Okay.
we love the days which this is all paper.
Okay.
You like digital or you like paper? Digital?
Digital.
Sure.
Yes.
Digital.
Because I feel like on paper you can pack so many things and it's much easier for them to make error grading. Like my U looks like a V. Like if they like, like they're gonna take points for that, like for that off. But if it's on digital, it's like okay. But like I think I don't know what my mom wants me to get on the final AP exam. But honestly, if I get a 4, it would be blessed. It would be blessed. Because according to my friend who's partially reliable, everyone at my school without a curve on AP physics would fail. Yeah.
Oh,
So they make the curve really big. Like I could get 50 on a test and they'll curve it up to 80 or 90. Because if they don't, everyone's like at 30%.
like I said, physics is a hell. In the beginning.
Mm, unfortunately, it's cool, but not fun. No, like fun in a cool way, but not easy to solve, like headache.
Yeah, the phenomena is fun. You always ask questions, but to understand deeper, yeah.
Yeah.
Mm.
Okay, 4? Okay.
Yeah. But your friend saying the one that's above your, right? It's the
What do you
data.
mean?
You mean they got a what? They got that score before, right? Because in your grade, people haven't taken AP much, right?
No, they're ninth graders taking AP,
Oh yeah.
like courses. Like ninth grade, 10th grade, 11th, 12th, there's people taking it. My friend didn't take AP because she took regular, but according to her, her friends who took AP failed it without the curve. With the curve, she did okay. I don't know like specifically what.
Wait,
Yeah, my friend was
what do you mean by curve?
I don't know if it's like on my school thing, even for IB exams, they give like curves, which is like adding extra points to what you have. So your raw score is like 20%, for example.
Oh,
With the curve, you might be like 70%. So they gave you like extra points for some reason. I don't know how the scores are converted, but I know they go by a really different scoring system than what probably College Board requires because they're doing that for IB. Like an IB final exam, 80%, I think 85% is a 7. But at my school, you have to get above 96 to be qualified as a 7.
really?
Yeah. So they curve differently for some reason. I don't know how though.
Hmm. As long as it's not lying, then that'll be okay. So anyway, let's do 4.
50?
Nope.
Okay. I'm not sure what would the acceleration be.
Hey, then how did you do? You're using 500 divided by 10, right?
Yes.
Yeah. G acceleration is 10.
Yes,
And
but how do I know if it's negative or positive 10?
well, first mass have to be positive, right? We're not doing
Why?
magic, right? Well,
Oh, yeah.
yeah.
Okay.
And that's one thing. And also, because it's in the same direction anyway. For example, if you think about your gravity is 500, which means positive is going down, so and then your acceleration is also in this direction, so which is also positive. So 500 over, you know, positive 10. If you're thinking about this one is negative 500, and then this one is negative 10, so it's also positive 50. Then again,
Okay.
they have the same direction.
Wait, so I got the right answer? Oh,
Yeah.
okay. I thought you said it was wrong.
Oh no, that is.
Okay.
Example 5.
66.75.
Yeah, I don't like the tongue that needs 6.
I
Good
have a
things here.
question.
Yeah.
Would AP, like, if you don't put units, would they give you partial points or would they even award you the point?
Well, you just do the units anyway. 50
Because
units.
I'll be honest, I'm not doing any units right now. Maybe I should.
You're not doing the units, but in the end, you should give a unit. For example, for this one, you might substitute in here, but in the end, you should have one. I
But then
mean,
how do I know the units here? Like, is mass in this formula always kg?
yeah, normally always
Okay.
kg. And also, if you get confused, then you probably should substitute the units anyway. Does that make sense? If you
Okay.
confuse, and also as you said it, it's a meter per second square or meter. It's a good thing to check. So it's so you don't have to write in the process. It's better to write in process, and this is gonna help you in the future. In the future, we'll learn a lot of things we don't really understand much, but the unit is helping with that. I mean,
Okay.
so I don't write units sometimes, a lot of times, but when it get complicated, I would just run all my units there. And also in this, in the end, you normally write the units at least
Yeah.
to check, not only for make sure your answer is complete. It's actually checking is a big step in physics. Maybe not that big step in math, but it's a really big step in
It's
physics.
still a big thing in math too.
Oh yeah, sure.
Chemistry too, for units of conversion.
Mm. So good things Pound and Newton's relationship, right? Right.
That do I have to remember that, or is that like gonna be
No,
given
no,
in the
no.
question?
Given.
Okay.
Mm.
I like given things. Okay.
Yeah, but 2.45, if you remember, that'd be good too. which means you have to time 4 to get a Newton, right?
Okay.
How about 6?
20?
Yeah,
But what's a magnitude?
20 Newton.
Like magnitude is just force, like normal,
Yeah,
like
yeah, the size of the force, magnitude,
okay.
as opposing to direction. As the vector force, you have magnitude, and you also have like a direction. This one don't ask, right? Remember normal force, right?
Yes.
Let's go with 7 then.
No, partially. I remember the questions.
Like a normal force is just the supporting force.
Okay.
Out of the 7.
Is this still not 20?
Yeah, but this one you use something to balancing that to find it. Last time you find gravity is 20, right? But this time is
Yeah.
because it's rest, and you know Newton's first law applying, so there must be a balancing supporting force, normal force, right? 20. Because
Mm,
that we know. We use 20 gravity, and we use Newton's first law. Does that make sense? Although it's the
okay.
same answer, but it's a little different process. Draw free body diagram. Free body diagram is the force diagram, right? Draw all the forces.
I vaguely remember.
Free body is just the, if you are free and all the forces on you and how you're gonna, behave yourself. So I just call it force diagram sometimes. So a ball
Okay.
sits at rest. What are the forces?
Gravity.
Yeah,
Yeah.
that's the
That's
only
it?
force. Yeah, that's the only force.
Yes?
If that's the only force, you have to accelerate, right? You can't be sit
Why?
at rest. Wait, because sigma F equals ma. You have a sigma of F gravity equals ma. You have got to have acceleration.
So 0? So it's equal on both sides?
Yeah, so there is another
Push
force other
F
than
okay.
gravity. Other than gravity, what's the force? What's the other force?
Push F pull?
No one pulls it, right?
Yes.
So it's the normal force, F supporting or F normal.
So is it going down or up?
Wait, supporting the earth, the ground is supporting, so it's definitely up, right? But this
Okay.
system, you have to be up to balance that downward gravity, right?
Yes.
Mg or Fg. Did it make sense? This is pretty quiet there. How about B?
There's a push, gravity, also F normal.
Yeah, right. F foot.
Is there also friction?
Um,
Or you don't count this one here?
we actually don't know, right?
Okay.
Mm. If they didn't mention, we don't really know because the ground might be smooth, right? Maybe
Okay.
not rough. We don't really know, so we're assuming no. Does that make sense? This is the thing
Okay.
about AP wants physics. If they want you to think about friction, they will say something. If they don't say anything about friction, which means we think there's no friction.
No friction. Okay.
No.
I can live with that.
See, in real life there is friction.
Yeah. Um, there's gravity, normal,
Yeah.
Constant velocity.
Wait, constant velocity is a force?
No, but I'm just saying that there's constant velocity.
Okay.
So I think there's a pull and a push
Why there's a pull, push?
because it's moving, right?
You,
So
you mean it's moving? Yeah. Which means it's probably
push,
moving to the right.
yes.
So that's why you kind of, get this kind of wind. Mm. So do you think if there is friction? How do you know there is friction?
Um, because but it doesn't mention friction here.
Yeah. Yeah, I think you can really have friction. If you have friction, how can you make constant velocity? If it is constant velocity, which means the Newton's first law is applying here, right?
Yeah,
So it has no friction. So there's no friction. Does that make sense?
yes,
Because horizontally, if there is friction, you gotta decelerate, right?
yes.
It's gonna be constant velocity. So I guess the first one and the third one is actually the same. Only F normal and gravity balance. Yeah.
Okay.
Although A and C seems different, right? Mm.
Yeah, but I guess it's the same because it's constant velocity.
So the hidden information is it's a frictionless ramp, right?
Yes.
Otherwise, how can you move on the ground without friction with the constant velocity? How about D?
That one's okay. It's C, except there's a force to the left, and that's just because of friction.
Yeah. How about E?
It's the same, except like normal force is on the surface, like it's perpendicular to the ground. Because I remember you said that. Um,
Yeah, perpendicular to the surface, right?
yeah, and then if it's rolling up with friction, then friction is pushing it down,
No. Okay.
and then
F,
F is the opposite
F
for the
friction is in
friction
this.
force.
But the is the normal force is still here, right? And this one is
Yeah.
still probably Fg, right?
Yes.
That's the, yeah. 29.
Wait, but this is tension. I don't remember anything about tension.
Oh. Hmm.
Wait, I have an idea.
Yeah.
Um, because um I'm like kind of tired, so I was looking at the time. Since we
Hmm.
have like around like 3 4 minutes,
Yeah.
maybe I could have the tension PPT. I could take notes on it and then finish some practice question from the previous section for
Okay.
homework. So I can bring the questions for tension. And then
Sure.
maybe we could do another like force question, like the one we just did or something.
Oh, fourth question? I mean, diagram
Yeah.
question?
No, like just like the
Oh,
Newton's second law question.
okay, sure. Oh, let me mention one time. There's not much thing about tension. Well, you might think we learned something about it. It's just nothing.
But I remember it was hard. I didn't really get it. And I think that's where we stopped too.
Oh, so tension is just first you have to
The
remember it's
force.
along the string,
Yes.
and the which is the direction that we normally judge by common sense. You pull in that direction, then it goes in that direction, right?
Yes.
So it hangs, right? It hangs there, so it's upward, right?
Yes.
Okay, let's do
No,
some.
isn't the force going down? Because gravity, you're when you're pulling on it.
Yeah, because you're pulling in there, but it didn't go, so there must be a tension upward.
Okay.
Kind of deduce that way, but the force thing. which is question 1 maybe.
I think A.
Have equal magnitude and form an action and reaction pair. So a person standing on a horizontal plane feels two forces: downward gravity and the upward supporting force. This is called balance force on the same object, which is the human, right? The human. But when we talk about action and a reaction pair, they are forces on different objects. For example, when in this kind of situation, the force coming from the ground that the person feels, and the force the ground feel from the person, that's action and a reaction pair. I mean, you should act on the different object. Does that make sense? It will not like this one on the same person, right?
So it doesn't form an action and reaction pair.
Yeah, so they have the same magnitude. Yeah, it's not the same. It is the same magnitudes, but B do not form an action and reaction pair. Does that make sense?
Okay.
So in this kind of situation, let's say force give the force from the person to the ground. Oh, the ground from wait, the force. Let me just write force, ground, and wait, ground and person, or force person to ground. So they are action and reaction pair. Does that make sense?
Okay.
From ground to person, or from person to ground, they are action and reaction pair. Does that make sense? And this two are on the one object, which is not okay. So Newton's third law, you have to remember. Actually, in our time, we have to memorize this. That they are same magnitude and in opposite direction, but also act on different objects. When you act on the same object, yeah. When you act on the same object, it's not Newton's third law.
Okay.
I think that could be it.
Okay.
So the question isn't here which one. Yeah, 9.
Gonna be like
8.
Yeah, like
yeah,
3.
8. Yeah. 8.
Tomorrow.
8. Yeah.
So
wait, we don't have class tomorrow.
Yeah, but like I'm free from camp. I have plenty 2 weeks of time to spare for SAT and everything. So it will be very focused, locked in study sessions.
Oh, it's good.
So I have plenty of time to do homework.
Oh, and also you can do the freeze rounds for the previous chapter. That's a lot of questions. Not a lot, a few questions.
We have SAT class on Sunday, right?
Yeah.
Okay.
And have a good, I guess, small vacation.
Could you text the homework in the group chat? Because I feel like I'm gonna forget.
Yeah.
Thank you.
Chapter exercises and wait, we did something previous one. We also get that example. Oh, the example is from 26.
Like 23?
Yeah, 23 to 26. And then that one is 1 to 8. I mean, I think. 23 to 26. And then 1 to 8. And then the drill. That's chapter 3, right?
I don't know, but I can
chapter
look.
4. Chapter 4. Review question. Chapter 4. This is 4 example questions, and then review questions. And then there's chapter 5. Which means example question.
Okay.
And I'm gonna write example in here. Oh. Okay, that's it.
Okay.
Have a good day. God bless you. Bye-bye.
Thank you. I'll see you on Sunday.
Yeah, see you Sunday. Bye.
Bye bye.